Okay, today we're going to review graphing inequalities in preparation for our new standard, which is graphing systems of inequalities. So we're going to review first. We have less than or greater than. Then we must remember that this is a dashed or a broken line. If we have less than or equal to, greater than or equal to, then we have a solid line. If we have x or y is greater than or equal to, then we shade above. Okay, if we have x or y is less than or equal to, then we shade below. Okay, now remember in special cases, the shading above, if you have a vertical line, then that means that we're going to shade to the right. In special cases, if you have a vertical line, then you don't have a below, then that means that you would actually shade to the left. So that's a review of the type of lines and how to shade. Now remember, the first thing that we must always do is to write the inequality in slope-intercept form. Okay, so that's the first thing we're going to do is we write the inequality in slope-intercept form. Okay, now that does it for the review. So now we're ready to talk about systems of inequalities, what they look like, and how we determine the actual solution. So first thing we're going to do is we're going to talk about how to solve a system of inequalities. All right, so to solve a system of inequalities, then what we need to do is you need to find a pair of ordered pairs that will satisfy all inequalities involved. Okay, so when we say that we've solved a system of inequalities, then that means that you've actually found at least one ordered pair that will satisfy all inequalities involved in the system. Now, to do this, what we're going to do is we're going to graph the inequalities on the same coordinate plane. All right, so to make this happen, the first thing we're going to do is graph the inequalities All right, keep in mind when you're graphing inequalities, the shading is actually part of the graphing. If you don't shade, then you have not completely graphed the inequality. After we graph the inequalities on the same coordinate plane, then we're looking for the solution. The solution set is then represented by the intersection or overlap of the graphs. Now, the easiest way to determine the intersection or the overlap is if we're going to use color pencils or markers. Color pencils probably work best because you don't have to worry about all of the ink bleeding through the papers. So those are all of your notes, and now we're going to look at some examples. Okay, our first system, we're going to have x is greater than or equal to 5, and x plus y is less than or equal to 3. Okay, this first inequality is already in the form that we can, the simplest form we can put it in, so we're ready to graph. So I know I'm going to have a solid line. I'm going to shade above or right. And since there's only an x, this is going to be a vertical line. Okay, when I go to the graph, I'm going to do this one in green. This graph will be green. For the second inequality, we need to subtract x, and we have y is less than or equal to negative x plus 3. All right, this is a solid line as well. This time we're going to shade below or left. Your y-intercept is 3, and your slope is negative 1 over 1. Okay, we're going to do this one in orange. Okay, so I'm going to start with the first one. I have x is greater than or equal to 5. So I'm going to go over to 5 on the x-axis, put a point, draw my solid vertical line, put arrows on the end, and extend through the entire graph. Shade above or to the right. So I'm going to shade to the right. All right, for the second inequality, my y-intercept is 3. I'm going to go up to 3 and put a point. My slope is negative 1. So down 1, right 1. Down 1, right 1. Down 1, right 1. And continue to do that. And then the opposite would be up 1, left 1. Up 1, left 1. All right. So that's enough points. We're going to connect these points using a solid line. I'm going to extend through the entire graph. And this one said less than. So we're going to shade below. Okay. So by looking at the graph, we see that our region of overlap is down here. Okay. So to check, then we're going to select a point that's in this shaded region. Any point you want to. So I'm going to take this point, and that point is 7, negative 6. All right, this is your x, this is your y. Is 7 greater than or equal to 5? Yes, so that checks for the first inequality. 7 plus a negative 6 is less than or equal to 3. 1 is less than or equal to 3. And that is true. It satisfies both of your given inequalities. Therefore, we have shaded the correct region. All right, for your second example, this is number 2. You have x minus 2y is greater than or equal to negative 2. And then you have x plus y is less than or equal to negative 1. You're going to subtract x. You have negative 2y is greater than or equal to negative x minus 2. And then you're going to divide by negative 2 to isolate your y. Each term by negative 2. Because you're dividing by a negative, we must flip that inequality. Okay? For the second inequality, I'm going to subtract x. And I have y is less than or equal to negative x minus 1. Right? Here, we're going to graph this first one using blue. Your y-intercept is 1. And your slope is 1 over 2. Up 1, right 2. Up 1, right 2. Down 1, left 2. Down 1, left 2. This is going to be a solid line. And it's less than, so I'm going to shade below, utilizing the entire graph. All right, the second one, we're going to graph in, we'll do it in brown. Y-intercept is negative 1. Slope is negative 1. Down 1, right 1, down 1, right 1. Up 1, left 1, up 1, left 1, up 1, left 1. Connect these with the solid line as well. And it says less than, so I'm going to shade below. So hopefully the region of intersection or the overlap is very obvious. And it's in this region. So I could take this point. So I'm going to check it using the ordered pair 0, negative 3. That's 0 minus 2 times the negative 3. It's greater than or equal to negative 2. 6 is greater than or equal to negative 2. And that's true. Okay, for the second inequality, check it in the second inequality. I have 0 plus negative 3 is less than or equal to negative 1. Negative 3 is less than or equal to negative 1. And that one checks as well. So we have shaded the correct region. Okay, we're going to do one more example. All right, and this example is going to be y is greater than 2/3 x plus 2, and y is less than 2/3 x minus 1. Okay, I'm going to do the first one in green. Already in slope-intercept form, my y-intercept is 2. I'm going to go up 2 and right 3. Up 2 and right 3. I'm going to go down 2, left 3. Down 2, left 3. I'm going to connect these with the broken line. It says greater than, so I'm going to shade above. I'm going to do the second one with the blue marker. Y-intercept is negative 1. Slope is 2 over 3. Up 2, right 3. Up 2, right 3. Down 2, left 3. Down 2, left 3. I'm going to use another dashed line. This one is less than. I'm going to shade below. There's no intersection. Therefore, there's no solution. Okay, we'll practice graphing systems of inequalities in class tomorrow. It will be very beneficial if you remember to bring you some markers or color pencils.